All right, here we go. Wait. What are we waiting on? Okay. What are we going to? What? Not a lot. But some. What show? I'm not even spoiling. I don't like that. All right, give me questions about your homework. Number 10. All right, so back to the iterations, right? Remember, what I want to do is I want to divide. That's right. And if I get no remainder, what is it? Just one. Just one. If I get a remainder of 1 or 0.25 when I divide by 4, it's what? Which is just I, right. If it's 0.5 or a remainder of 2, yes, I always write it 1, 2, 3, 0. So now I'm having to go back and second guess myself. And then if you get a remainder of 3 or 0.75, it's negative I. That's exactly right. So when I do 49 divided by 4, what do you get? 4.25 or whatever, 0.25, which tells me this is just equal to I. Does that make sense? Something 0.25, yeah. 12.25. What else from your homework? That's the answer, just I. So, yeah. Put I anytime you see it. What you really want to do is if you end up with one remainder, if it's ever I, do that instead of square root of negative 1. And if it's ever a remainder of 3, always do negative I. I's are okay to keep in it, but anything else you don't really want to keep in it. So you'll use 1, negative 1, I, and negative I are what you'll use. Does that make sense? What else on your homework? Well, if you don't need help, we don't gotta do it. It don't matter. Yeah. Ow. 18. Flip it over on the back. 18. So now we're solving, right? 18 minus x squared equals 39. So I'm going to get the x squared by itself. So the first thing I'm going to do is move that 18 over. Yes? All right. Minus 18. I got negative x squared equals 21. How do I get rid of that negative right there? Okay. X squared is negative 21. Now what? You square root it. That's exactly right. I'm going to square root both sides. I end up, this is where we want to really remember our plus or minuses whenever we're solving equations this way. So I'm going to have plus or minus. Remember, when you see this negative inside here, drop that negative and put an I on the outside. So I get I times the square root of 21. And now I check to see, can I do this, right? So can I? No. So I leave it just like that. What else? It will be, and if you were absent, just when you submit it, put a note in the comments that says I was absent. Go back and watch the video and look at the notes, and then do it before you try to do it without it, and then I'll help you understand. All right, anything else? Oh, I'm sorry, 20. Number 20, that last one. I'm sure this is because there's a fraction in it, right? Y'all don't like fractions. I'm going to add 15 to both sides. So I get negative 4/3 x squared equals 216. How do I get rid of that fraction? There you go. There y'all go. I'm going to flip this over to negative 3/4, and that's what I'm going to multiply both sides by. I get x squared equals, let's see if I can do this in my head. 4 goes into 216, 5, 54. 54 times 3 would be 12. Carry, is that right? Is that right? Negative. Now square root. I'm going to go ahead and do the I, and then we'll break it up. So you took out 81. 81 times what? 81 and 2. So I end up with plus or minus square root of 81 is what? 9I root 2. There you go. Look at y'all go. Look at y'all go. All right. Well, let's switch it up. Get a notebook. Get it figured out? No? Oh my gosh. All right, here we go. Complex numbers. Yesterday we talked about imaginary numbers. Imaginary numbers just have an I hooked to them. That's all you have to remember, okay? Complex numbers, though, have two parts. They have a real number. What's a real number? It's the things you're used to, right? 5, 7, 10, a half, 3/4, any of those. Those are all real numbers. They can be positive or negative. And then to that, I'm going to add or subtract some imaginary number. And together, those make up a complex number. So, maybe I have 3 plus 2i. That's a complex number. It's got a real number part. It's got an imaginary number part. Okay? So together, am I blocking or can you just not see me? Is that better? That's okay. Well, there's not really anything to solve right now because there's nothing to put together, right? But we're going to talk about operations with complex numbers. Give me another example, though, of a complex number. Somebody randomly. Go ahead. That's a complex number. It's complex because it's got a real part and it's got an imaginary part. You see how easy that is? All right. Is anybody confused on what a complex number is? A real number plus an imaginary. That's all you have to remember. Now, the hard part with complex, and it's not really even hard, it's a great lesson for a Friday because it's not too bad. We're going to add, subtract, multiply, and divide these complex numbers, and we're going to talk about what happens when we do that. Okay? Are y'all ready? No? Ready or not? All right, let's add, subtract first. This is the easiest. Bless you. That's quite all right. Somebody give me any complex number you can think of. Anybody? 6 plus 4i. Thank you. Somebody else, give me another one. 7. Let's do minus. Hard, even random numbers is hard to come up with them just whenever you put on the spot, isn't it? I feel you. All right, so if we add these, this is one complex plus another complex, yes? So what I'm going to do, can you guess before I tell you? That's exactly right. All we're going to do is combine like terms. That's it. Okay? It is that easy. So put the real number parts together. 6 plus 7 is what? Y'all can do this. 13. 4i and negative 8i is what? Negative 4i. That's how you add complex numbers. That's the answer. It is that easy. We can mix it up and throw some imaginaries in here as well. And I'm going to make this one subtraction. Let's see what happens. One more. Let's do, y'all take too long to come up with them. 3i minus 7 plus 2i. Let's make this one plus and this one minus. 77. I like it. Minus. Now look what I have. I have imaginary plus a complex minus a complex. Okay? Where's the air coming from? Does it have a unit? No, it's two sides. No, it is. Yeah, but where is like? Is it coming out of the ceiling? You think? That's what those are? Where you see it? Yes, I do. All the way down. I just heard it come. I might have to flip that. I don't know. That's like the old radiator. Is it all right? There's no telling. Those things have been in here since like Noah's Ark. Like they've been in here a long time. Okay. Let's get the real number parts together first. And let's be careful here because notice the subtraction sign. When that subtraction sign precedes a parentheses, or comes before the parentheses, that means everything in here is subtracted, right? So I'm subtracting 77 and I'm also subtracting negative 10i. So be very careful, okay? All right, so real number parts. What do you see that doesn't have an I on it? 7 and 77. What is 7 minus 77? Negative 70. There's my real number parts. I'm going to mark them out because I'm done with them. Now let's put my i's together. I have 3i, 2i. Now careful because I've got minus negative 10i. So 3 and 2 is 5. What is 5i minus negative 10i? Positive 15i. If you're a same change kind of person, come here. This is going to same change, and then you change everything in the second parentheses. So change and change. Okay, that might make it easier for you if you have trouble seeing it. Or multiply the parentheses by -1. That's exactly right. Everybody okay? Don't need to spend any longer on adding and subtracting complex numbers. If yes, speak now. Don't be ashamed. A little bit, one more. Let's do one more. 15 came because it was, all right, so I had 3i plus 2i, and then I had minus negative 10i. All right, let's do one more. Let's do a subtraction one. Let's do 12 minus 3i. Try this one on your own. Minus 27 minus I. All right, what'd you get for your real number? 12? No. I was looking at it. I thought y'all said 13, and then I went to do it and went, that's not right. Okay, negative 15, and then I've got negative 3i minus negative I. Look at y'all go. Well, yes, so that's what we call standard form of a complex number. The real number comes first, followed by the imaginary. Not wrong if you do it the other way. It's just pretty nice. That normally that comes first, right? All right, y'all ready to multiply? Ready or not? That's right. Multiply and divide, that's all we got left. This should be an easy day for you. I don't have you a lot of work. I'd like to give you time to get it done since it's Friday. Yeah, I'll help you with it. All right, multiplying complex. Here's what we do. I'm going to say complex and imaginary because we'll throw some imaginaries in there too. Let's say that I have 2 plus 7i times 5 minus, and I need to multiply those. What am I going to do? Distribute. You're exactly right. You're exactly right. You were hesitant when you said it, but you're exactly right. I'm going to distribute or FOIL this, okay? Y'all remember how to do that? 2 times 5 is what? 10. 2 times negative 3i. There you go. Now the next one, so that's distributed to everybody. Now distribute the 7i. 7i times 5. 35i. And then 7i times negative 3i. There you go. Now what happens with I squared? That's exactly right. Remember yesterday I told you if you ever see an I squared, drop the I squared and just change the sign of the number. I'm going to take this and I'm going to change it to plus 21 and drop the I off. Does that make sense to you if I do that? Does it make dollars? Oh, just kidding. Okay, now let's gather our like terms together. Nobody even laughed when I said that. Are y'all that immune to my corny jokes now? Already. I said, does that make sense? And y'all said, yeah. I said, does it make dollars? I appreciate it. Did I say the same joke? Oh. Oh, did they? Probably because I say it all the time, they started saying it too. All right, let's combine like terms. Let's put the whole numbers first, or the real numbers first. I got 10 and 21, which gives me 31, nice. And then I've got negative 6i and 35i, which would give me positive 29i, and there is my solution. That is exactly what you're doing. All right, let's divide because that's the hard part. Kind of chilly in here. Thanks, Harris. Mister, it's hot in here with the sweatshirt on. You were freezing. You might still be sick. Yeah. It is definitely not freezing. All right. This one's going to be the hardest, so stay with me, okay? Okay. I'm going to divide this. I'm going to show you how to divide by an imaginary and how to divide by a complex. This is the one time when it is a little bit different. All right, so let's divide by imaginary first. Before I do that, let me ask you, if I had 5 over 3i, do you notice anything that is wrong with that? Why is the I in the denominator? Everything's wrong. Okay, let me rewind back. When you first learned about radicals, you know that you can't have a negative under the radical, yes? There's also another rule with radicals. You can't have them where? In the denominator, right? They cannot be in the bottom of a fraction. And remember, whenever we did get them in the bottom of a fraction, what did we do with them? Multiply by themselves. If I had 2 over the square root of 7, then to get rid of that square root of 7, I multiplied the top and the bottom by square root of 7, right? And that gave me 2 square root of 7 over 7. And then that's what I had. So the problem with this is because what really is I representing? What's it? A negative what? Radical, right? That radical of a negative number. So really this is 5 over 3 times the square root of negative 1. Do you agree with that? Okay. Tyler, tell me what I equals. Just I. Square root of negative 1. But I can't have a square root in the bottom. That's a problem, right? Before, when I had a square root in the bottom, I got rid of it by multiplying it by itself. I'm going to do the same thing with i's. To get rid of this square root of negative 1, I'm going to multiply by square root of negative 1 in the top and bottom. But instead of calling it square root of negative 1, I'm just going to come here and multiply the top and the bottom by I because that's the same thing. And I'm going to put you a note here. Multiply top and bottom by I. Okay? I just wanted you to see why we're doing that. We're doing that because really we're just getting rid of that radical in the bottom. Okay? When I do that, what happens to the top? 5i, right? There's not anything I can do with that. What does the bottom become? 3i squared. What do you do with a number with I squared hooked to it? You drop the I squared and you just change the sign, right? So this is not 3i squared. It's really negative 3. So this is 5i over negative 3. Now I don't have a radical in the bottom anymore, and it's A-okay. Are y'all okay with that? Yes. Remember, it doesn't matter what's in the top, it's just the bottom. Let's say this one's a little bit harder. Now I've got a complex divided by imaginary. I'm only worried, bless you, about the denominator here, okay? I'm dividing by an imaginary, so what am I going to do to take care of that situation? Multiply by I on the top and the bottom, right? Oh, whoa, look at the top there. I absolutely would. That I is going to distribute up top. So I've got 2I minus what? 5I squared over, that is exactly right, 10I squared. So Thomas already said, wait, that I squared on that 5, and he's exactly right. This is going to become plus 5. What's the bottom going to become? Negative 10. So let's write our fraction now. And I'm going to switch it around. I'm going to do 5 plus 2I. Just so that the I comes second, you don't have to do that. If you put 2I plus 5, that's fine. Over negative 10, and I'm done. Okay? Y'all okay? Because I'm fixing to crank it up. One more scenario, and I'm done. If I divide by a complex number, is that not what I was doing already? What was I doing over there? Is that a complex number? It's an imaginary number. Different than a complex is made up of a real and imaginary on the top, but I'm talking about what I'm dividing by. Okay? Now, here's why this is different. Let's say I have, and I'll do an easy example to start with. Let's say I have 5 over 2 plus 7I. Okay, so let's see don't write this down yet, because I want you to see why it doesn't work, okay? If I use that same thought process and I just multiplied by I and by I, I'd end up with 5I over 2I plus 7I squared. That's negative 7. Again, don't write this, just watch. 5I over negative 7 plus 2I. What's the problem here? And it's never going away, right? The issue what I was trying to eliminate is still there. The problem is the I in the bottom, and it's still in the stinking bottom, right? Oh, it's still there. I keep hiding in the bottom. So that's not going to work when I've got a complex in the bottom. So I got to back up and plan. If I'm dividing by a complex, I'm going to teach you a little trick. Oh, it won't let me erase any more than that. That's okay. I'm going to multiply the top and the bottom by what I call multiply top and bottom by the conjugate. Have you guys heard of a conjugate before? What's a conjugate? Oh, not that kind of conjugate. Okay, this is a mathematical conjugate. All right, here's what a conjugate is. A conjugate keeps everything the same except the middle sign. Nice try. So if I wanted the conjugate of the bottom, what do you think that would be? Look at this fraction. Change the middle sign only. So what's the conjugate of 2 plus 7i? 2 minus 7i. And remember, if I do it to the bottom, I have to do it to the top. But I want you to take just a minute, and I want you to FOIL that bottom out and tell me what happens. Just take just a minute on your paper to go off to the side and FOIL out 2 plus 7i times 2 minus 7i. Yeah. Who's done foiling yet? What happened? Did y'all hear? The i's cancel out. Oh. So in fact, every time we multiply conjugates of complex numbers, the i's go away. That's what I wanted, right? I need there not to be an I on the bottom. So now all I have to do is do the same thing to the top, which is multiply by the conjugate. So on the bottom, did everybody get 53 for that, by the way? All right. I'll do another one. All right, so the bottom, when I multiply these two together, I get 53. Up top, I get 10 minus 35i. Now is my fraction okay? Yes, because there's no I in the bottom. The I in the bottom is what the problem is when the problem occurs, because we can't have a square root in the bottom. Okay, so if it's an imaginary in the bottom and just an imaginary, I'm going to multiply the top and the bottom by what? If it's just imaginary, just I. But if there's a complex in the bottom, the problem is much more difficult, right? I have to multiply by the conjugate top and bottom. Let's do one more example, and then I will set you loose. I'm going to make this one just a tad harder. Yeah. Welcome. Is that better? Or even bigger still? Is that better? You can't see it? All right. Try this one on your own. Find the problem and fix the problem. Mark, set, go. If you got it, you can welcome. Let's go ahead and start on your homework. I'm going to multiply because the problem is in the bottom. So I'm going to multiply by the conjugate of the bottom only, okay? 5 plus 2i, top and bottom. I don't know if I can write in this big old marker now. All right, here we go. I'm in two FOIL situations, yes? All right. 3 times 5 is 15, plus 6i, plus 5i, plus 2i squared. That's for the top. Now for the bottom. 5 times 5. 5 times 2i. That's right. Negative 2i times 5. And negative 2i times 2i. Negative 4i squared. All right, let's do what we know. Cancel out those 10 i's on the bottom. That's right. Every I squared, drop it and change the sign. This is going to be negative 2. This is going to be plus 4. All right, let's do the top first. 15 and negative 2, 13, and then 6i and 5i, 11i. How about on the bottom? I got a 25, those are gone, and a 4. 29. Pow.